Welcome back again. It's good to see you again. Alright, I hope that you have been improving all this while in your physics. And this afternoon we are going to study on waves. And the specific aspects that I'm going to touch on is on speed, frequency, and the wavelength of the waves. And this applies to any waves, whether it be light waves, electromagnetic waves, water waves, mechanical waves. As long as it is a wave, it applies. Let us look at some of the other things first. Now, I'm encouraging you to have this mindset that you would want to improve now. Even if you improve a little bit after my lesson today, it is a good sign. As long as you improve step by step, after many days, many lessons, you find that you are a much better and more capable physics student. For my lesson today, at the end of this lesson, it is my dream that you will be able to solve numerical problems involving speed, frequency, and wavelength of waves. Once again, I would like to remind you, always go for questions. Answer questions, look for some more questions, and write down the answers, solve it. And as you answer a lot of questions, you have learned. It is not by reading. By reading, you would not be able to learn effectively. We need output revision. Alright, let us quickly jump into the question now. In this question, number 27, let's read it. In the deep section of a ripple tank, the speed of the waves is 20 centimeters per second, and the wavelength is 4 centimeters. When the wave moves into the shallow section of the ripple tank, the wavelength is 3 centimeters. What is the speed of the wave? Now let us just get an idea of what is happening here. Alright? Now what I'm going to do is this. I would like to sketch you a simple diagram to let you know exactly what is happening. Alright? And with the diagram, you would get a clearer picture. Alright, let's say this is the ripple tank that we have. Alright, let's say this is the top of the ripple tank. Okay, and then I put a piece of glass here. And this is the water. Alright, so what I do is, let's say this ruler represents the vibrator. The vibrator on the side of, I call it X, from X to Y. Okay, so there is a vibrator on X. And this vibrator, it will hit the water surface. Remember the experiments that you did in class, in the lab? Alright. And this particular frequency of the vibration, it is constant. Alright. You know that it doesn't change. In this particular case, we have it as a constant. It does not change. So, from my little diagram, I just sketch it. You know that this is the deep end. And this is the shallow section of the water. Alright. So as we move from the deep end to the shallow end, there is a change in the wavelength. There is a change in the speed. Alright. So this will give you a good picture. Now let's take a look at the values now. 20 centimeters per second in the deep end. That is the speed of the waves. And the wavelength is 4 centimeters. When the wave moves into the shallow end of the ripple tank, the wavelength becomes 3 centimeters. Now, I would like to encourage all of you to do what I have always been advising you. That is, when you write down a quantity, always have the subscript. Now, what do I mean? The speed of the waves in the deep section. So I call it VD. The speed in the deep section. Alright, 20 centimeters per second. Alright. And what about the wavelength? Wavelength in the deep section, it is 4 centimeters. Get it? And what about the 3 centimeters? It is the wavelength in the shallow section. Alright, so lambda is the wavelength, shallow I use S. It is better to use the words rather than using numbers, because if you use 1 and 2, then you have to think what it represents. But since it is the deep section, you use D. And since this is the shallow section, you use S. Alright, so this is 3 centimeters. Alright, so far so good? Now, because I need the space, I'll just erase the diagrams at the bottom there. Alright, I'll do my calculations here and show you what happens. So what you do is this. Step by step, write down the words in the deep section. Alright, in the deep section of the ripple tank, what do I have? I have this too. Alright, I have V, I have lambda. And remember, we look at the formula page. See, it's very clear, isn't it? Now, what is the formula that we need to use? V equals to F lambda. Now, this is given to you in the examination. Alright, so V equals to F lambda. V equals to F lambda. Alright, now what is V? It is VD. Lambda D, because this is the deep section. Now for F, I would not write down D, because whether it be the deep section or the shallow section, the frequency of the vibrator is constant. It is kept constant. Alright? Good. So now what I do is, from this first equation, I will work out the value for F. Alright, what is VD? 20 centimeter per second equals to frequency multiplied by lambda D. Lambda D is 4 centimeters. The wavelength in the deep section, 4 centimeters. Alright, so from this equation, I know that the frequency is given by 20 centimeter per second divided by 4 cm. I would get 5 hertz or 5 per second. Okay, if you write down 5 per second, it is perfectly alright, or 5 hertz. So far so good? Alright, now we will proceed and answer the next section. The next section is, I will make use of this value. The wavelength in the shallow section of the ripple tank is 3 centimeters. But the frequency is still 5 hertz or 5 per second, or 5 cycles per second. Alright, so I'll use these two values. Okay, what is the speed of the wave in the shallow section? V equals to F lambda. Alright, I'll just do it here. Alright, so V equals to F lambda. V of the shallow section equals to F multiplied by lambda in the shallow section. Alright, what is F? 5 hertz or 5 cycles per second multiplied by lambda S. Now lambda S, we wrote it as 3 centimeters. Alright, 3 centimeters. So what do I get? I get 15 centimeter per second. See, again, I have taught you all to write down the subscript, because the subscript is very meaningful. I have also taught you again and again to write down the units. When you write down the units, it is very useful. At the end of your calculation, you know that the units take care of itself. You have centimeter per second. And centimeter per second, this is actually the unit for speed. So, Vs is the speed of the waves in the shallow section, and it is 15 centimeter per second. So follow my advice, follow the tips that I have given to you, so that you use these tips not only for this section of your physics, but in any section of your physics. So once again, I'm very sure that now you can solve you are able to solve numerical problems that involves V, F, and lambda for waves. All right, I can see that you are happy. And when you are happy, I am also happy. All right, thank you. May God bless you. I'll see you again the next round.